Hello viewers, Wagada now taking you through the story for A-level pure mathematics. So in this video we are going to go through the topic of simultaneous equations and inequalities. So this topic is under algebra and is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So so far this is our course outline, and like I've already told you, math paper 1 or pure math is divided into 5 parts. One is algebra, where two questions come in section A and 2 in section B, and these are the topics. Then next is trigonometry, where 1 comes in section A and 1 in section B, and these are the topics. Next is geometry, where 1 comes in section A, 1 in section B, and these are the topics. Next is vectors, where 1 comes in section A and 1 in section B, and these are the topics. And lastly is calculus, where 3 come in section A and 3 in section B. So in calculus, you realize that there is this topic which has not yet been covered. The reason is because it needs knowledge on this topic called inequalities. So in this video, we are going to look at these two topics, simultaneous equations and inequalities, after which you shall be able to understand the topic of curve sketching for rational functions. Now simultaneous equations, the good thing, you covered them also in O-level, and you covered both these methods. There's elimination method and substitution method. The only difference is that in O-level we are dealing with only 2 variables, x and y, or a and b, like that. But in A-level we consider also 3 variables. So in A-level they can give you a simultaneous equations having 3 variables like x, y, z, or ABC, or it can be having 2 variables like in O-level. So that is the only difference, but the methods which were used are the very methods. So there's nothing to write. Let's go straight to the worked examples. So question 1 came from UNEB 2014 paper 1 question 1 and says solve the simultaneous equations. So they give you, these are the 3 simultaneous equations. So if there are 3 simultaneous equations, it implies that the unknowns are also 3. So in this case we shall first label them. This will be equation 1, this will be equation 2, and this will be equation 3, as you can see them here. The next is you to choose the method to use. You can either choose substitution method or elimination method, but questions on this form, it is easier to use elimination method. So what you are going to do, we are going to first eliminate z, and to eliminate z from equation 1 and 2, what you are going to do, we shall get this equation 1 and also this equation 2, multiply the equation 2 by 2, and then add the 2 equations. So when I add the 2, so this equation 1 is this one, and this equation 2 multiplied by 2 throughout gives you this. I think you realize that 2x times 2 is 4x, 3y times 2 is 6y, z times 2 is 2z, 1 times 2 is 2. Now when I add these 2, you realize that x plus 4x gives you 5x, negative 2y plus 6y gives you 4y, negative 2z plus 2z gives you 0, so the z is eliminated. So that is what they mean by elimination. Then 0 plus 2 gives you 2, which is that. So we shall call this one equation 4. Then we shall also need to get another equation having only x and y. So in this equation 2 and this equation 3, what you're going to do, you shall multiply 3 throughout this equation 2 and add it to equation 3. So when you do that, this is what you're going to get. So 3 times 2x gives you 6x, 3y times 3 gives you 9y, z times 3 gives you 3z, 1 times 3 gives you 3. So this is equation 2 multiplied by 3 throughout. Then this is equation 3, you'll come and put it here as it is. Then next is we are supposed to add. When we add, we shall come up with this, and this gives you 9x, this and this gives you 8y, this one cancels, and this one becomes 6. So in that case we have got 2 equations, equation 4 and equation 5, with only 2 unknowns, x and y. So there it means that now it is easier because we just employ the knowledge of O level. So what you're going to do, we shall get this equation 4 and multiply 2 throughout that equation 4, and then also subtract equation 5 from the outcome. So 2 times this gives you 2 times this gives you 10x, 2 times this gives you 8y, 2 times this gives you 4. Then this is equation 5, you come and write it as it is. But we have to subtract the 2, so this minus this gives you x, this minus this cancels, and this minus this gives you negative 2. So in that case we have got the value of x. Then from equation 4, from this, it implies that we can substitute x and be able to come up with the value of y. So y will be equal to 3. Then from equation 2, we can substitute for x and y and be able to come up with the value of z, and z will be negative 4. So in that case, we shall conclude that x is negative 2, y is 3, and z is negative 4. So basically, that is elimination method. I think you have realized that's the same as the one for O level. So the only unique part is in the part of substitution method, because substitution method we are going to add in something unique, as we shall see in this question. So question 2 came from UNEB 1989, paper 1, question 1a, and it says, given that A over B is equal to C over D is equal to K, show that K is equal to A plus C over B plus D, and hence solve the simultaneous equations, these ones. So in substitution, this is where the uniqueness comes in, because I think we realize that here we have 2 equal signs. So how do we deal with that? The first thing to do, let's first prove this identity with this expression which they have given us. So this one means that I can equate this with this to come up with this line, therefore A is equal to KB. Then also I can equate this with this to come up with this line, implying that C is equal to KD. Therefore, I'll start now from the right hand side. So right hand side is this. Therefore, come and substitute for A. Where there is A, put there this, and where there is C, put there that. You realize that in this numerator, K is common, so you pull it out and in bracket remain with B plus D. Then from there, when you compare the numerator with the denominator, you realize that B plus D and B plus D can cancel, you remain with only K. So in that case, this has been shown. So showing, nowadays they no longer restrict, you can either start from this side or this side. So you have chosen to start from the right hand side. Now we shall go to the hence part. So the hence part means they want you to use this identity to solve these simultaneous equations. So what we shall do, shall say that, remember here, if you look at this expression, this K was the same K here when these 2 numerators were added and also these 2 denominators were added. So that is the same thing we are going to use. We shall say that when this one is equal to K, it implies that that K will be the same when all these 3 numerators are added, as you see it here, and also when these 3 denominators are added, as you can see it there. So that is what they mean by hence. Hence means that start from this expression. So that's where I started from. Now we are going to simplify the numerator to come up with this. Then this denominator will become that. Then from there, remember we have got this from equation 1. What about this equation 2? There's something unique here. You realize that 4x plus 2y plus 5z, okay, let me first remove this. So 4x plus 2y plus 5z is the same as this numerator. So what does that mean? It means that where there is this numerator, you are going to replace it with this 30. So come and replace it with 30 and be able to come up with that expression. Therefore K is equal to 2. So now that you have got K equal to 2, it implies that you can come and do them independently. Say this one equal to K. So when this one is equal to K, it implies that that is equal to 2, implying that x plus z for z is equal to 8. Then also when this one equating it to K, which is 2, you'll come up with that. Therefore that is equation 2. Then also this one equated to K, you'll come up with this, which gives you equation 3. So now we have got 3 equations and 3 unknowns. Therefore, we can solve them simultaneously by using either elimination method or substitution method. Because the question will not be specific that use this method or that method. It is up to you to choose the one which is easier for you. So equation 2 minus equation 3 will give me z minus 3x equal to 2. Therefore, when I make z the subject, z will be equal to 2 plus 3x. Bring this 3x this side. Then now from equation 1, I'll come and substitute for z. I'll be able to get an equation with only x as the only unknown. So collecting like terms, I'll be able to get the value of x as 0. Now from equation 3, we shall be able to come up with, substitute for x here, and be able to get the value of y. Then from equation 2, I'll substitute and be able to get the value of z. So in the end, x is 0, y is 10, and z is 2. So now we shall go to question 3, which came from UNEB 1994, paper 1, question 1b, and it says, solve the simultaneous equations, these ones. So I think we realize that these simultaneous equations are similar to the ones in question 2, so we shall use the same concept. So let this one be equal to k. What does that mean? It means that when I add all the numerators and put them here, then also add all the denominators and put them here, they will still be equal to k. So simplify the numerator gives you this, and simplify this gives you that. Now when you realize that this one, the challenge is that now here there is 3, 3, 3, and here there is just x, y, z. So what did we do? It implies that pull out 3 to remain with x plus y plus z, which is similar to this. So questions of this format, what you get here in the numerator will always be somehow similar to the one in the other equation. So then now that means that this one will be replaced by 2. So when you do that, we shall come up with that. Therefore, the value of k is equal to 1. After getting the value of k, come and equate this first term into 1 to get the equation 1. Then you get the second term also equate it to 1 to get the equation 2. This third term equate it to 1 to get equation 3. Now these are 3 equations and 3 unknowns, meaning that we can solve them simultaneously using either substitution or elimination method. So equation 2 minus 2 times equation 3 gives you that expression. So this is equation 2, and this one multiply 2 throughout, you'll be able to get this equation. Now when I subtract the 2, this one cancels. Now y minus 0 is y. Here there is no x, so it means that 0 minus 4 gives you negative 4. So that is why you see here a negative there. Then 4 minus 10 is negative 6. So when I make y the subject, y will be equal to 4x minus 6. Now from equation 1, I'll come and substitute for y to come up with that equation which has only x as the only unknown. Therefore, expand and collect and simplify to make the x the subject, x will be equal to 1. Then from equation 3, I'll come and substitute for x to be able to get the value of z. And from equation 2, come and substitute and be able to get the value of y. Therefore, x is equal to 1, y is equal to negative 2, and z is equal to 3. So now we shall go to question 4, which came from UNEB 2005, paper 1, question 14a, and it says, solve the equation this and that. So still, this one is similar to the previous question, so we shall still use the same procedure. First thing to do is to let the whole of this be equal to a constant k. Then remember that the sum of the numerators here over the sum of the denominators will be still equal to the value of k. So simplify the numerator gives you this, and simplify this denominator gives you this. Then from there you have to compare, like I told you, or this numerator will be somehow similar to this other equation. So the difference is that here there is 3x and here there is 6x. So what does that mean? It implies that now from this, when I divide throughout by 2, this will become 3, this will become 3, this will become 1, and this will become 3. Therefore, this numerator here is equal to this, which is 3. So I'll come and substitute to come up with that. Therefore, the value of k is a third. Now that I've got the value of k, I'll come and equate k to each term. So equating it to the first term, I'll be able to come up with equation 1. To the second term, I'll be able to come up with equation 2. And to the third term, I'll be able to come up with equation 3. Now those are 3 equations and 3 unknowns. So what we are going to do, it is due to choose either elimination or substitution method. So let me begin with elimination method. So equation 1 minus 12 times equation 2 will give you that. And when I subtract this minus this gives you, sorry, we're adding. So when we add this plus this gives you 0, and this plus this gives you positive 15y, and this plus this gives you 16. Therefore, make y the subject and y will be 16 over 15. Then from equation 1, from this equation, I'll come and substitute for y to be able to get the value of x as 17 over 15. Also from equation 3, this one, I'll come and substitute for y and be able to get the value of z as negative 18 over 5. Therefore, x is 17 over 15, y is 16 over 15, and z is negative 18 over 5. So now we shall go to question 5, which came from UNEB 2019, paper 1, question 10b, and says, solve the simultaneous equations this. So still we shall say, for this, let this one, I think we realize that these are 2 equal signs, so let it be equal to a constant k. That means that x is equal to this. When I equate this to this, I'll come up with this, this to this, I'll come up with this, and this to this, I'll come up with that. Therefore, from this second equation, I'll come and substitute for x, y, and z to be able to get an equation, a quadratic equation in terms of k. So multiplying throughout by the LCM gives you that, and collecting like terms will give you that. So that is a quadratic. I'll have to solve it using either factorization method or bulldozer method. So if I choose bulldozer method, this will be the substitution, and therefore k will be 8 over 3, or k is equal to negative 4. Now for k equal to 8 over 3, it implies that x is equal to 4 over 3, y is equal to 8 over 9, and z is equal to 2 over 3. What about for k equal to negative 4? X will be equal to negative 2, y will be equal to negative 4 over 3, and z will be equal to negative 1. And now we shall go to question 6, which came from UNEB 2020, that is last year, paper 1, question 14a, and says, solve the simultaneous equations, this and that. So from this, it implies that y is equal to 6 minus x. Now I'll come and substitute for y in this first equation, and that is what I'm going to get. Where there is y, I'll put there 6 minus x. So this is what we call substitution method. So when I open brackets for this, I'll come up with this, and this one, expand this bracket, I'll come up with this. So open the brackets further, I'll come up with that line, then collect like terms, I'll come up with that quadratic equation. I can choose to divide throughout by 9 to come up with this quadratic equation, a simplified one, and then I can either use factorization or bulldozer method. So in this case, I'll use factorization, and it will be x minus 2, x minus 4 equal to 0. And that means that x is equal to 2 or x is equal to 4. But I also want the values of y. So when x is equal to 2, come here and substitute for x to be able to get the value of y as 4. And when x is equal to 4, come and substitute and be able to get the value of y as 2. So basically that is what they wanted. Now we shall go to question 7, which came from UNEB 2017, paper 1, question 13a. And it says, solve for x and y in the following simultaneous equations. So we have these two simultaneous equations. Now from this second one, to imply that make x the subject, it will give you 11 minus 8y over 3. Then from this first one, come and rewrite it and then substitute for x to be able to get an equation with only y. So in this bracket, get the LCM to come up with this expression. Then collect like terms, negative 8 minus 12 gives you negative 20. Then now you open brackets, take this one this side, that is why they will see 9 here. Then open brackets for this gives you this. I think you remember that expansion. So rearrange to get a quadratic in terms of y, simplify, and then use either factorization method or bulldozer method. So in this case we have used bulldozer method, and therefore y will be equal to 7 over 10 or 2 over 5. When y is equal to 7 over 10, x will come here and be able to get the value of x, which is 9 over 5. Then when y is equal to 2 over 5, come here, still substitute for y and be able to get the value of x as 13 over 5. So now we shall go to question 8, which came from UNEB 2007 paper 1 question 14c, and says solve simultaneously this equation and that equation. So equation 1 is that, and equation 2 is this. When I make b the subject, b will be equal to 2 minus a. Let me call it equation 2. Now from equation 1, I know that this one can be factorized to become this, which is a plus b, one factor, another one will be, another bracket will be a squared minus. So note here that when this is plus, here it will be minus. So that is under algebra still. So a squared minus ab plus b squared. So it will still be equal to 26. Now the good thing, I know that a plus b is equal to 2, so I come and substitute to come up with that. So when I take this one this side, I'll come up with 13, because 26 over 2 is equal to 13. Then from there, I'll realize that this one still in identity is the same as this. Therefore, come and substitute a plus b is equal to that, but there's a square, that is why you put square here. Then this and this gives you minus 3ab equal to 13. Now, I already know that b is equal to 2 minus a, so come and substitute for b here to get an equation with only a. So that is a quadratic equation, and when I solve it, I'll be able to come up, I can either use factorization method or bulldozer method. So if I use factorization method, I'll come up with a minus 1, a minus 3, a plus 1. And therefore a is equal to 3 or a is equal to negative 1. Now from equation 2, when I've got a, I can be able to get the value of b. So when a is equal to 3, b will be equal to negative 1. And when a is equal to negative 1, b will be equal to 3. So now we shall go to question 9, which came from UNEB 2001 paper 1 question 1, and says solve the simultaneous equations, these ones. So that will be equation 1, and this will be equation 2. When I rearrange it, I'll come up with y equal to x plus 1. Therefore from equation 1, I'll come and first rewrite it, and then I'll substitute for y. Then expand, this one gives you this expansion. Then I have to collect like terms and simplify the quadratic equation in x. Then solve it either by factorization method or bulldozer method. So in this case, I've used factorization method. Therefore x is equal to x is equal to 6 or x is equal to negative 2. Now from equation 2, I'll be able to get the value of y. When x is 6, y will be equal to 7. And when x is negative 2, y will be equal to negative 1. So now we shall go to question 10, which came from UNEB of March 1998, paper 1, question 1, and it says solve the simultaneous equations, these two. Now from this one, I can rearrange, take this one this side and bring this one this side to come up with this expression. Then get LCM for this left hand side, which is that. So that means that y is equal to 6x over 6 minus x. Now that I've made y the subject, I can come now to this second equation and then substitute for y. After that, I'll have only x as the only unknown, so I can cross multiply, then expand, and get a quadratic equation. So factorize it, I think realize that x is common throughout, so first pull out x in brackets will have a quadratic. Now that quadratic you can either factorize or use bulldozer, so in this case I'll factorize to come up with those two factors. Therefore x is equal to 0, or x is equal to 2, or x is equal to 9. Now when x is equal to 0, come here, y will be equal to 0 because this is 0. Then when x is equal to 2, come and substitute here to come up with y as 3. And when x is equal to 9, come and substitute here to come up with y as negative 18. So that has been simultaneous equations. Now we shall go to the other part, which is inequalities. Now for inequalities can be solved by considering signs of factors, and the following steps are needed. So now in inequalities, unlike in O-level, the inequalities for A-level require much attention because they will be a little unique. For O-level, you used to use something like number line and you could get the answers, but this time that it doesn't work because the inequalities we use here are no longer for linear, but they are for quadratics or higher degrees. Now the following steps need to be taken. So when given an inequality, step 1, take all the functions to the right hand side and do not cross multiply. Sometimes the inequality is given will have a fraction, and students usually tend to cross multiply because they are used to that. But in this question of inequality, do not cross multiply, because the moment you cross multiply, everything will be vague. That is step 1. Step 2, determine the LCM and use it to obtain a compound fraction. Do not multiply throughout by the LCM. So this, most students also, when they get the LCM, they tend to multiply throughout by the LCM. So in this case, we do not multiply throughout by the LCM. So this should be taken. You should take in on this because most of you are used to these steps. But in this case, we don't cross multiply, and 2, we don't multiply throughout by the LCM. We only get a compound fraction. We shall see what a compound fraction is in the worked examples. Then 3, determine the critical values of the compound fraction. Now these critical values are got separately by equating each of the factors in the numerator and denominator to 0 to get the value of x. So we shall see what critical values are, but in simple terms, you just equate the numerator to 0 and get the factors and get the values of x. Also equate the denominator to 0 and get the values of x. Those will be the critical values. Then step 4, use the critical values to obtain the signs of the compound fraction for the given interval. We shall see how that is dealt with, because you need now to tabulate. Unlike in O-level, you just draw a number line, but here we have to tabulate some values, as you will see in the solutions. And lastly, step 5, determine the solution set which satisfies the given inequality in the question. So this is very vital, and we shall explain more about it as we go through the worked examples. Now note, for modulus inequalities, you must recall that this magnitude means square root of the whole of this squared. So sometimes in some inequalities will involve these two bars. Those two bars mean modulus, and that is how they are expanded. Square root of whatever is inside squared. So with those steps, let's see how those steps can be used to answer some of the questions. So question 1 came from UNEB 2020, paper 1, question 1, and it says solve the inequality this. Now, like I said, step 1, do not cross multiply. So if by mistake you bring this one this side, that will already be vague. So do not cross multiply. What do you do? Bring everything on one side. So bring that to this side to come up with that. Then after that, we say that do not, after getting the LCM here, the LCM will be x plus 2 because this is 1. But this caution is that do not multiply throughout by the LCM. What do you do? You just get a compound fraction. In other words, get this LCM and combine these two into a single fraction. How? Put the LCM down, then you say this LCM divided by this is 1, then 1 times this gives you this part. Then this minus is maintained. Then this LCM divided by 1 is this, then times this gives you that. So that is what we mean by a compound fraction. Next is to simplify this compound fraction. So when I simplify, I'll be able to come up with that. By this one, this can still be simplified further to come up with that. So that is what we call the compound fraction. Now next is to get the critical values. But remember, critical values, you have to factorize both the numerator and the denominator. So here we shall have to factorize the numerator and denominator. So here there was -2, but the factors you have to get two factors whose sum is -2 and product is -15. And those two factors are 3 and -5, because 3 minus 5 is -2 and 3 times -5 is -15. That is why you have replaced -2 with 3x minus 5x. Then now here 3x is common here for this part, and here 5 is common, -5 is common. So pull out 3x here to remain with that, pull out -5 here to remain with that. Then this and this is common. Therefore, I can pull it out to remain with 3x minus 5, which is this, and this side will be that. Now that I've factorized, I can be able to get my critical values. Now the critical values, we said, equate this one to 0, and separately, and also equate this one to 0. So when I equate this one to 0, I'll come up with x equal to -2, which is this. Then equate this one to 0, I'll come up with x equal to -1, and for this one I'll come up with x equal to 5/3. Now that is what we call the critical values. Next is to tabulate the given interval. So how do we tabulate? Let's see the inequalities. First of all, these ones must be arranged in ascending order. I think realize that this is small, this is followed by this, followed by that, so they have to be in ascending order. Then next, you are going to write down all these factors separately. So we have started with this, followed by this, and lastly that. Now when that is done, you are going to write the whole of this here. Therefore, when that is done, now the next is to put the inequalities. The first one, remember inequalities, you deal with ranges. So the first range is for x less than this first critical value. So that is why you put here x less than -2. Now x less than -2, you choose any value. For example, any value less than -2 can be -3. So let's use -3 as our test value. So when I put -3 here, I'll come up and I look at the sign. The value I'll get will be a negative. Now we are not interested in the value you get. Our interest is the sign. That's why you only see a negative here. Then put -3 here, you'll also get a negative. Put -3 here, you'll also get a negative. Now this expression says this times this over this. So this times this, it will be a sum, because negative times the negative gives you a positive. Now positive times the negative gives you a negative. That is why you put a negative here. Then the next range is between this and this. So the inequality will be x greater than -2 but less than -1, because it has to be between this and that. So a value between that two can be -1.5. So let's use that as our test value. Put this one here, you'll be able to get a negative. Put it here, you'll be able to get a negative. Put it here, you'll get a positive. Therefore, in the end, this and this gives you a positive, so in the end it becomes a positive. Then the next interval, we have finished the one before this, and we finish the one between this and this. Now the next is the one between this and that. Now between -1 and 5/3, we shall come and write it here. So here it should be -1, not 2. So -1 and between x greater than -1 but less than 5/3, you will come up with, so the value can be what? The value, let's say -0. Okay, let's just put 0 because 0 is between. So let's put 0. Now when I put 0 here, I'll come up with a negative. Put also 0 here, I'll come up with a positive. Put 0 here, I'll come up with a positive. Now all these ones, because negative times a positive gives a negative, so in the end you'll come up with a negative value. Like I said, this should be -1. Now the next, we are finished. Before this, we are finished between this and this, we are finished between this and this. Next is after that. So we shall put here the inequality of x greater than 5/3. So these ones, by default, all of them will be positive. Okay, so now that is our table. Next is to answer the question. When you go to the question, they said greater than or equal to 0. That means that this function must be positive, because all numbers greater than 0 are positive. So that means that this one is eliminated. Negative values are eliminated. Now you are left with this and this, which is that and that. Therefore, we shall come and conclude that the solution set is x greater than or equal to -2 but less than or equal to -1, and x greater than or equal to 5. So we use these inequalities, but now someone may ask, why are we using greater than or equal to, yet here it was just greater than? The reason is because of the question. The question, when you look at in the table, we don't add any or equal to, we don't add them there in the table. But in the conclusion, you look at the given inequality. The given inequality has or equal to. Because it has this or equal to, even our answers must have the or equal to. That is why we write this one, but this time we put the or equal to because it was there in the question. Here I also put or equal to because it was there in the question. Here I also put or equal to because it was there in the question. So that is how you conclude your solution set. Now we shall go to question 2. Question 2 came from UNEB 1996, paper 1, question 3, and says, solve the inequality this. Okay, so now like I said, the first mistake students may make is cross multiplying. As long as we see that we have cross multiplied this with this and this with this, that is already vague and there's no mark awarded. So always be keen on the first step. Take everything on one side. Then the second step, don't multiply throughout by the LCM. What do? Just get a compound fraction. I think you know how to get the compound fraction. Look at the LCM, then you say this times this will give you this, and this times this will give you that, in simple terms. Then expand the compound fraction. Then you have to collect like terms. So when I collect like terms, I'll come up with that expression. Now these ones are already factorized, so what I'm going to do, I'll have to get the critical values. Critical values, like I said, equate this one to 0, you'll be able to come up with x equal to 7 over 6, which is that. Then equate this one to 0, you'll be able to come up with this will give you x equal to 2, and this will give you x equal to -3. Now we have rearranged them because we said the critical values must be arranged in ascending order. Then from there we can now come and tabulate our values. So first this factor is here, this one is here, and this one is here. Then lastly we write the whole of this expression, compound fraction, which is that. Then we shall start. We're starting for our inequalities. Start with the values less than -3. -3, we shall come up with that. Let us use the test value of -4. So put -4 here, you get a negative. This, put it here, you get a negative. Put it here, you get a negative. So the resultant of this will be also a negative. So we have finished values less than that. Now what about the ones between this and this? So we shall come and write that inequality for values between -3 and 7 over 6. and here you choose any value. Because this is negative positive, let's use 0. So 0 here you'll get a negative, 0 here you'll get a negative, 0 here you get a positive. So the resultant will be positive. So we have finished this. We have finished the one between this and this. Now next is between this and that. So we shall come and write its inequality. So here we shall use the value. Let us use the value of this is greater than 1. Let's use 1.5. So 1.5. So 1.5, put it here, you'll come up with a positive. Put it here, come up with a negative. Put it here, come up with a positive. So in the end, the resultant will be a negative. So we have finished the one before, the one between this and this, and between this and this. Now the last one is the one after that. So by default, I've told you that will always be positive. But I can also check if you want, but it will always be positive. Okay, so now after that we shall look at this inequality greater than 0, meaning that we are interested in positive. So this will be cancelled out, and this will be cancelled out, and we remain with this and this. Therefore, we are interested in this inequality and this inequality. So we shall come and write that the solution set is this and this. I think you realize that now here we have not put or equal to, because if you look at the question does not have that or equal to. It only has greater than. Therefore, if the equation doesn't have the or equal to, don't put it there. And if it has, make sure you put it here. And also, whether the question has or equal to or not, in this table, don't put or equal to. So now we shall go to question 3, which came from UNEB 2017, paper 1, question 13b, and says, find the set of values of x for which this is less than that. So the first thing to do is to put everything on one side to come up with that. The next is to factorize. So here are the factors whose sum is positive 5 and product is negative 24. They are 8 and negative 3. So this 5x will be replaced by 8x minus 5 minus 3x. Now these two, 4x is common, and here negative 3 is common. So come and factorize out 4x here, remain with x plus 2. Factorize out negative 3 here, remain with x plus 2. Now x plus 2 is common here, so therefore we shall remain with 4x minus 3, which is this, and x plus 2, which is that. Therefore the critical values, here we don't say that x is less than this and x is less than. From here we get critical values. Now critical value for this, equate this to 0, you'll come up with that, and equate this to 0, you come up with that. But remember, they have to be arranged in ascending order. That is why you have started with negative 2 and followed by 3 over 4. The next is to tabulate. Tabulating, you shall write these factors. Write this one there and also this one there. Then the whole of it, which is there. Then from here, the inequality starts with the values less than negative 2. So come and write x less than negative 2. This will give you negative, and this will be negative. So in the end, you shall come up with a positive. So we have finished these ones. What about the ones between this and this? We shall come and write its inequality. Then here it will be negative, here it will be positive, so in the end it will be negative. We have finished between this and this, so the next is after that. So we shall come and write the inequality. Then by default, all those ones will be positive. After that, we shall look at the inequality less than 0, meaning that it should be a negative. Therefore, this is off, and the interest is this. So we shall come and look at this inequality, and that is be the solution set they wanted. So now we shall go to question 4, which came from UNEB 2009, paper 1, question 4, and says, if y is equal to this, find the range of possible values of y for real x. So in that case, what we do, we have to first cross multiply, bring this one this side to come up with that. Now here we allow cross multiplying because this is not an inequality. So when I cross multiply and rearrange, I'll come up with a quadratic in x. So quadratic in x is that. Now remember, this is now our a, this is the b, and this is the c, abc. Now for real x, we always know that b squared minus 4ac is greater than or equal to 0. So we shall come here and substitute for b, for a, and for c. So when I expand and simplify, I'll be able to come up with a quadratic. Factorize the quadratic because we have to look for factors whose sum is -3 and product is -4, and those are -4 and 1. Therefore, come and replace -3 with -4 plus 1. Factorize out here, factorize out 4y to come up with that. Here, factorize out 1 to come up with that. Now, this is common, therefore you shall remain with 4y plus 1 and y minus 1. So at that step, we have to get the critical values. For this equal to 0, you can get this equal to 0, come up with that. Arrange in ascending order, that's why we began with -1/4 followed by 1. The next is to tabulate. So tabulate, write this one, write that one, then write the entire expression, which is that. So you are beginning with values less than this, which is that inequality. So here to be negative, here to be negative, in the end it becomes positive. Then between this and this, it will be, the inequality is that, therefore here to be positive, here to be negative, in the end you get negative. Then after that it will become, the inequality is that, so here to be positive, by default all are positive. So after that you look at this inequality, it means that we want positive values, so this one is off. Therefore we shall come and conclude that the range is y is less than or equal to -1/4 and y is greater than or equal to 1. I think by now you know why we are putting this inequality and not this. So now we shall go to question 5. Find the solution set of the inequality this. So now this one has a modulus. So I think you remember the note we made about modulus. So it means that the whole of this is put under square root, but you have to square it. Then from there you square both sides to come up with this. So this squared is 9, this one is that, this one is that, when you square. Then take everything on one side to come up with that. Expand this gives you that, expand this gives you that. Then collect like terms, you come up with that. Factorize, you come up with that. Therefore critical values are 0 because equating this to 0 is 0 and equating this to 0 is that. Therefore next is to tabulate. Bring this term here and also this term there. And after that you write the entire term. So we shall start at these ones. Less than 0, before the 0 you come up, that is the inequality. This gives you negative, this gives you negative, so in the end you get a positive. Then between 0 and 3/2, the inequality is that, and here it will give you positive, here it will give you negative, so in the end you get a negative. And after this, the inequality is that, so by default all are positive. So after that we shall look at this inequality, less than 0 meaning that we need negative. Therefore this is not out and this is also out. Therefore the required inequality solution set is this. I believe by now you know why we are using this inequality and not this. So now we shall go to question 6, which says find the range or ranges of values of x, or values x can take for this. So still there's a modulus, so we shall use the definition of modulus. Square both sides, take all the terms on one side, open, expand, this gives you that and this gives you that. Collect like terms, factorize. So when I factorize, I'll come up with that. Next is to get, after factorizing, you have to get critical values. This one gives you this, and this one gives you that. But they have to be arranged in ascending order. That's why we began with -3 followed by +3. The next is to tabulate. So tabulating, bring this term here and also bring this term there, and then the entire term, which is that. So now this constant, you can either put it there or you ignore it. There's no mistake in that. So start with the values less than that, so the inequality is that, and here to be negative, negative gives you positive. Then between this and this, the inequality is that, so it gives you negative there, positive there, so in the end you get a negative. Then beyond this, the inequality is that, so by default all are positive. So less than 0 meaning that we're interested in the negative, so these are out, this is out, and this is out. Therefore the solution set will be that. And So now we shall go to question 7, which says that find the solution set of the inequality that. So we shall first write the given inequality, but remember there's modulus, so we shall use the definition to come up with this expression. I think you remember that. The next is to square both sides to come up with that. The next is to take everything on one side to come up with that. And next is to get the LCM and get the compound fraction. Now from there, I'll come and open bracket, expand this to come up with that. The denominator is not expanded, you just leave it as it is. Then open the entire bracket to come up with that expression. Now from here, I think you realize that now here the inequality was less than or equal to 0, and here it is greater than or equal to 0. Why? It is because we have divided through by a negative. So dividing through by -3, both this side and this side will give you, that's why the sign changes. So each time you divide by a negative, the sign has to change. The inequality sign has to change. That is why now here it was less than or equal to 0, and here it is greater than or equal to 0. Now when I factorize this, I'll come up with that, and this will be our compound fraction. Now the critical values will be, this gives you 2, this gives you 3, and this gives you 6, arranged in ascending order. The next is to tabulate our values. Start with values less than this, so let's first write the factors. So the factors, there is 1, which is this, and there is also this, and there is also that. Then the whole compound fraction is that. So just start with values before that, the inequality is that, and this is positive, this is negative, negative, in the end you get a positive. Then between this and this, the inequality is that, and here it will be positive, positive, negative, negative. Then between this and this, the inequality is that, and here it is positive, positive, negative, negative. Then beyond this, the inequality sign is that, and by default all are positive. Okay, so if you look at this inequality, greater than 0 means that our interest is positive, implying that these ones are off. Therefore, we shall come and conclude that the solution set is x less than or equal to 2 and x greater than or equal to 6. I believe by now you know why we are using these inequalities. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on indices, sets, and logarithms. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on indices, sets, and logarithms has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that you can all benefit as a family.